Welcome to The Explainer. Today, we are jumping right into a step-by-step masterclass on industrial automation. We're going to take you from foundational theory, literally the absolute basics of how machines run themselves, all the way up to advanced professional system orchestration. Whether you're a total beginner or an industry pro looking to sharpen your mindset, you are definitely in the right place. Okay, let's dive into this syllabus. We're going to build your knowledge block by block. We'll start with the automation foundation, move into the 4 types of automation, open up your industrial toolkit, map out the entire factory hierarchy, and then wrap things up with the massive Industry 4.0 shift. Section 1, the automation foundation. Because honestly, to wrap our heads around the incredibly complex systems of a modern chemical plant, we really need to ground ourselves in the absolute basics first. So let's look at how the Cambridge Dictionary defines automation. It's simply the use of machines and computers that can operate without needing human control. That is the ultimate goal here, right? Getting humans out of the loop. And we do this because when you remove manual input, you drastically improve accuracy, you cut down on labor costs, and you practically eliminate waste. It's all about letting the technology seamlessly handle all those repetitive or highly complex activities. Now, you might naturally think of automation as this super modern concept, but the history here is actually mind-blowing. People have been trying to automate things for a really long time. Think about this. All the way back in the 3rd century BC, over 2,000 years ago, a Greek inventor named Ctesibius designed a water clock with a float regulator. That is literally the earliest known feedback-controlled mechanism. Fast forward a bit to 1785, and Oliver Evans invents the automated flour mill. Then, by 1947, the term automation really takes off when Ford Motor Company establishes an entire department totally dedicated to it. And then, bam, the 1950s hit, bringing us numerical control and the very first specialized industrial computers. Moving on to Section 2, the 4 types of automation. This is where we transition from history right into real-world professional application. So I want to pose a question directly to you. How do you actually automate a massive chemical plant or, say, a beer factory? Put yourself in the mindset of a factory architect for a second. If you are designing a real-world production line from the ground up, how do you even begin categorizing all those moving parts? Well, as you map out your factory, you're going to rely on 4 main types of automation. First, there's fixed automation. This is for your super high-volume set tasks, like a dedicated bottling line that is physically built to do just one thing incredibly fast. Then you've got programmable automation. Think of a brewery turning out different batches of beer. You can reprogram the sequence of operations electronically for a stout versus an IPA. Third is flexible automation. This one is heavily computer-controlled for products that change all the time, like a CNC machine carving custom parts on the fly. And finally, integrated automation. This is the whole shebang, where independent equipment, processes, and massive streams of data are working synchronously across the entire plant. Now, why do we need all these different types? It really comes down to the evolution of production itself. Back in the day, we relied heavily on batch production, making one batch of chemicals or beer, stopping, and then starting the next. But as early as the 1930s, companies like Dow Chemical realized they needed continuous production, where materials just flow constantly without stopping. And you simply cannot run a continuous process by hand. You absolutely need advanced integrated control systems to keep it all safe and efficient. Which perfectly brings us to Section 3, your industrial toolkit, because pulling off that continuous production requires some very specific heavy-duty tools. And the absolute rock star of this toolkit is the PLC, or Programmable Logic Controller. Now, this is not like the delicate laptop sitting on your desk. A PLC is a specialized, extremely ruggedized computer built to survive harsh industrial environments. We're talking heavy vibrations, crazy high temperatures, and tons of electrical noise. They act as the localized brains of the factory floor, processing inputs and triggering outputs using logic-based programming. And the very best part is their incredible flexibility. You don't have to physically rewire the machine for a new task. You literally just update the code. And the data flow brilliantly illustrates exactly how this toolkit works together in sequence. Step 1. Sensors out in the field gather real-time physical data. Imagine a temperature sensor inside a massive brewing vat. Step 2. That data shoots over to the PLC, which processes it based on its programming. If the vat gets too hot, the PLC instantly tells a cooling valve to open up. Step 3. Systems like SCADA, which stands for Supervisory Control and Data Acquisition, and HMI, or Human Machine Interface, step in. They translate all that raw technical data into a nice visual dashboard, so a human operator sitting in a control room actually knows what's happening and can make those higher-level decisions.
All right, Section 4, the factory hierarchy. Let's talk about how all these tools are physically and digitally stacked up across a sprawling facility.
This hierarchy is literally the backbone of industrial automation. At the very bottom, you have the field level. This is the physical world. It's your sensors gathering data and your actuators, like motors and valves, doing the actual heavy lifting. Moving up one step, we hit the control level. This is where our PLCs live, constantly pulling in that field data, computing it, and executing logic in real time. Then, sitting at the very top is the supervisor level. This is where you find your industrial PCs running that SCADA and HMI software, giving human supervisors a complete visual overview of the process. So basically, data flows up and commands flow down.
But here is a critical engineering detail you definitely can't ignore. Because of this hierarchy, the power differences across these levels really matter. Down at the field level, those massive motors require heavy-duty three-phase alternating current. But up at the control level, your delicate PLCs are running on just 24 volts of direct current. So you absolutely must have a robust industrial power supply and incredibly strict safety protocols to bridge these levels safely. Otherwise, you're risking catastrophic failures. Finally, Section 5, the Industry 4.0 shift. Time to elevate into an executive mindset and look at exactly where this is all heading. We are smack in the middle of the fourth industrial revolution, widely known as Industry 4.0. We are moving way past just having an isolated PLC control a single machine. Now it's all about the industrial Internet of Things, the IIoT. It's the seamless integration of all these physical objects into a massive interconnected virtual network. Factories aren't just automated anymore. They are becoming adaptive, sensing systems that actually learn and optimize themselves across the entire value chain. Now, what's really interesting about this technological shift is how it's completely flipping factory economics upside down. According to Bain & Company, automation value used to look like a pyramid, with most of the money sitting in that traditional control hardware in the middle. But today, it looks like an hourglass. Over 50% of the industry's profit pool is shifting up to the software and data-driven layers. Meanwhile, smart, connected field devices at the bottom are grabbing another 25 to 30%. That traditional hardware middle is rapidly shrinking. The real value is now found in software, data, and continuous intelligence. And the payoff for getting this right? It is massive. Bain's research shows that factories successfully making this transition, the ones coordinating this continuous intelligence across all their machines, can see huge productivity gains of 30 to 50%. Not to mention, they drastically lower maintenance costs and significantly extend the lifespan of their most expensive heavy-duty assets. That's a real game changer. Honestly, this quote hits the nail on the head and perfectly summarizes everything we've talked about today. Industrial automation is no longer about controlling machines. It's about orchestrating intelligence. Think about the journey we just took. We went all the way from the simple mechanization of ancient Greek water clocks, mastered programmable PLCs, and now we are orchestrating incredibly smart, fully connected systems in the era of Industry 4.0. So as we wrap up this masterclass, I want to leave you with this final, provocative thought to carry into your professional work. As you look at the facilities of tomorrow, will your systems just control basic operations, or will you build them to orchestrate continuous intelligence? The choice you make there is going to define the entire future of your production line. Thank you so much for joining me on this explainer, and I hope this deep dive has sparked some serious curiosity for your next automation project.